Welcome to my new video. This is an Itel 20,000 amps power bank. You can see the name Itel. So this is a 20,000 amps power bank from the Itel. So a customer brought this to me and said that the light, that is the indication light, they are not showing. That is, the power bank is not bringing out light. So I opened the power bank and trying to trace what the issue could be. So now I'm connecting the battery back to the piece to the panel to still troubleshoot the panel again. Let me see. So now I can see that the light is working, that the touch light is working, as you can see. So now let me try and test the charging. Let me plug my phone to the power bank and see if it's going to charge my phone or not. Then I'll know the next step to take in order to troubleshoot the power bank further. So now let me get my cord now, because the indication light that's supposed to show is not indicating. The light is not showing. So now let me get my USB cable and then let me plug my phone to it and then test and see. So let me use my phone and this is my cord. So now let me plug it to the power bank and let me try and unplug. You can see that it is charging. It's charging my phone, but the light is not showing. You can see the light is not showing. So this is an issue with the power bank. So if it's not showing this light, how will you know if it is charged or not? So now we are going to fix it. I'm going to show you how to fix this. You can see I unplug it and plug it back. It is still charging. So now let me remove the cord and then put the phone and the cord aside so that we can troubleshoot the panel and see what is wrong with the panel or with the bulb. So now I'm going to get my soldering iron now, and then I'll get my soldering iron. Then I'm going to disconnect the battery from the PCB. Anytime you're working on the PCB, please ensure you disconnect the battery from it, especially like in case of power bank. Disconnect the battery from the PCB in order to have a safe work so that you don't get other component damaged in the process. So now I'm going to put the battery aside now. So now I'm going to work on the PCB. You can see this is a PCB. So the first thing we are going to check on this PCB, first thing as a technician, is you are going to check for physical damage. Physical damage. That is the first thing whenever you want to troubleshoot a panel. Check for physical damage. So now I'm checking the panel if there's a physical damage or not. So I'm checking all the resistor, capacitor, component, and so on. You can see I have not detected any physical damage on this side of the panel. So I'm going to turn it over and then I'm still going to check. Let me check for physical damage if there is anyone on the panel. So now I'm checking it. I'm trying to clean the panel so that I can see it very well. So now let me brush it. Let me brush it very well so that I can see it very well. So let's check for physical damage. Engineers, please take your time when you're checking for physical damage. Okay, I've seen one. You can see this is a physical damage. You can see all the resistors that controls the light indicator. You can see that two of them are broken. We have two of them. You can see it. Let me ring for you to see. You can see it's supposed to be 6 in number, and now we have 4. Two of them have been broken. I don't know what caused this, but this is a physical damage. So now we are going to replace those resistor. Those are resistor. You can see the label there, R2, R3, R4, and so on. So now we are going to replace it from a scrap panel. This is why I say don't throw away your scrap panel or sell it to all those aboki. Keep them because they're going to be useful at any time. So now I'm using my chemical to clean the PCB I want to remove the resistor from. So now I'm cleaning it with my chemical now. You can see it. So now I'm cleaning it so you can see. I'm trying to clean it well. So now let me return back the remaining chemical into the container and then cover it. So now I'm taking the PCB. You can see this is my scrap panel. So now I've gotten a lot of resistors on it. So now I'm going to remove two out of these two. I'm going to use my soldering iron and then remove those two because I'm going to use it to replace it on the power bank panel. You might be wondering how am I sure it's going to be okay with the power bank? How am I sure the value are going to be okay? Now, one thing I want you to know is that these surface resistors that you see in all these microelectronics is that most of them that have the same sizes, the values are mostly the same, except the one that has a bigger size. That is when the value is going to be different. Okay, so when the sizes are the same, bear in mind that the value are also the same, because micro resistors like you see like this, they don't build them to be different from each other, except in the case of bigger electronics like television, radio. All these big electronics is those ones that have different values most of the time. But this micro component that you see, their sizes is what they use to measure their values most of the time. If you even take your multimeter and read it, you're going to see the sizes is what matters most. The size can determine the value of each one. So if their sizes are the same, you will see that uh, they are going to work together. So now I'm replacing it now. That is the first one I'm fixing. So take your time, engineers, and do a good work. Don't rush. Take your time. Take your time. That is why I'm taking my time now. Take your time and do a good work for your customer. Take your time and do a good work, okay? Take your time. Don't rush. Take your time and don't allow it to bridge with another one, okay? Take your time, engineers, and do a good work. My table is shaking. That is why the video is like this. My table is shaking. That is my tripod stand is shaking. That is why you can see it. So now I'm done with one side. So now I want to solder the second side now. Take your time. Take your time, engineers. Take your time and do a good work for your customer. Don't rush your work. Take your time and do a very good work for your customer. Take your time. Okay. Take your time and do a good work. Don't rush. Don't rush. Okay. And make sure as you're doing this work, don't allow it to bridge. Avoid short circuiting the resistors. Don't allow it to bridge. Don't allow it to be short circuit. Okay. So you can see I'm trying to check it so that it's not bridge in any way. I want to make sure it's not short circuit in any way. I want to make sure that each point is soldered correctly. Okay. So engineers, please take your time. As you can see me, I'm not rushing. I'm not rushing. You can see I'm done. You can see it clearly for yourself. You can see it. I'm done. I've soldered the resistors. I've replaced them. So now I'm going to check it. You can see I'm going to connect it to the battery and test. But first and foremost, I want to test it with the charger if it's going to show. This is a charger. You can see it's showing, but there's a problem. You can see the last one, that is the first one, I mean, is not showing. The first bulb there is not showing. What could be the problem? The first bulb is not showing. So now I'm still going to trace my soldering. Let me see. I'm going to trace it. Let me trace what the work we just did. Okay. So trying to check it. So let me use my soldering iron and still resolder it again. Let me see. Let me resolder it again. I want to make sure the two resistors are well soldered to the PCB to make sure there's no partial contact anywhere. Okay. Trying to make sure they are well soldered. There is no partial contact anywhere. Okay. You can see. You need to make sure there is no partial contact at any point, that they are well soldered to the PCB. You can see. I'm done. So now let me use my charger again. You can see it is still like that. So you see that it's showing from beginning, but in the process it will cease. So I believe that fault is not from the work I just did, but it is okay. You can see. So our work is done. You can see it is showing from beginning, but at the process it will cease. So I'm going to connect my battery. I'm going to connect the battery to it. Let me see. Let me test it also and see if it's going to be the same or not. So now let me connect my battery. Connect the battery to the panel. Let me connect my battery now. Take your time, engineers. Don't rush. Do a good work for your customer so that they enjoy your service and come back again. Okay? Do a good work. Don't rush. Don't rush your work. Okay? Don't rush your work. Let me clean them out of the soldering iron. So now trying to I'm fixing the battery now. Yeah, just for testing. Yeah, let me solder the battery to the panel and test. I want to test it. I'm soldering it now. You can see I'm done with the soldering. So let me press you can see the bulb is showing now. You can see that it's showing. So now let me plug my charger. You can see that it's working. Boom. So our work is now done. So it's because there's no battery to the PCB. You can see that it is working. You can see. So congratulations to us. The work is done. You can see everything is working. You can see. So engineers, take your time and troubleshoot any work a customer gives to you and don't rush it. Take your time and do a good work for your customer. So now I'm trying to charge it with my phone. Let me use the power bank and charge my phone and see if it's working or not. So I'm plugging it to my phone now. You can see that it's charging my phone. As you can see, my phone is 76%. You can see that it's charging my phone. So now you can see we are done with the work. You can see, please engineers, take your time and always do a good work for your customer. Thank you for watching this video and see you again in my next video. Bye for now. See you again. I love you. Bye.